Hello everyone, my name is Min and now I'm going to present about our group mini project. Now we're going to look at the question 1. The information given is the region R is bounded by x equal to 1 over 2 y squared minus 3 and y equal to x minus 1. The question asks us to sketch the graph for the bounded areas, and we will use the formula given to find the positions of the coordinate in the graph. From the question x equal to 1 over y squared minus 3, we can find that when y equal to positive and negative square root 6, x equal to 0. And when y equal to 0 and x equal to negative 3. The second formula is y equal to x minus 1. When x equal to 0, y equal to negative 1. And when x equal to 1 and y equal to 0. Then we will set the first equations into the second equations. We will find y squared minus 2y plus 8 equal to 0. And after we factorize it, we will get y equal to 4 and y equal to negative 2. When y equal to 4, then x equal to 5. When y equal to negative 2, x equal to negative 1. Now we will get an intersection point with coordinate 5 in x value and 4 in y values, and negative 1 in x value and negative 2 in y value. Here is the graph plotted, and the shadow region is region A. We need to find the area of the shadow regions, and we integrate x1 minus x2 with upper boundary of 4 and negative 2 for lower boundary. At the end, we will find acting units. Now we're going to question number 2. Region Q is bounded by rotating x equal to y squared minus 4 and x equal to 6 minus 3y about the line x equal to 24. The question asks us to sketch the graph for the volumes of solid by rotating the bounded of region Q. So same with the question 1, we need to find the coordinate, need to plot on the curve first. We use first formula x equal to y squared minus 4 to find the coordinate xy. When y equal to positive and negative 2, x equal to 0, and when y equal to 0, x equal to negative 4. For the second equations, when x equal to 0 and y equal to 2, and when x equal to 6 and y equal to 0. So the next step is same with question 1 too. We sub the first equations into the second equations. X equal to 6 minus 3y, and we do it at the end. We will get y squared plus 3y minus 10 and equal to 0. And we factorize it. Y plus 5 equal to 0 and y equal to negative 5. And the other y equal to 2. And then we find the x value. When y equal to negative 5, x equal to 21, and y equal to 2, x equal to 0. So at the end, we will get intersection points, 21 in x value and negative 5 in y value for first coordinates, and the second coordinate 0 in x values and negative 2 in y value. Now we're going to see our graph, and the shadow region is region Q. This is our graph, and the shadow region is region Q. For question 2b, the question asks to prove the volumes of Q, which is 31,556 over 50 pi by using the method of disk. So we will use integrations to solve the problems. Volume equal to integrate pi x1 square minus x2 square with upper boundary 2 and lower boundary -5. Before we solve the problem, we need to know that what is the x1 and x2 value. X1 value is 20x minus y squared, and x2 value is 3y plus 18. We sub x1 values and x2 values in the formula and we integrate it, and finally we prove that the volume of Q is equal to 31,556 over 50 pi unit cubes.
The question number 3 is, the region B is bound by rotating x equal to y minus 2 power of 2. The x-axis and the y-axis about the x-axis. The question is A. Sketch the graph for the volume of the solid by rotating the bounds of region B. We can use the point of x equal to 0 and equal to 4. Substitute inside the y minus 2 power of 2 equal to x. So we can get the y value is 2 and y equal to 0. So in the graph, we can use the point of 0, 4 and 2, 0 to sketch the graph. The region B was shown is 0, 0 to 0, 4 and 0, 0 to 2, 0 as a picture. 3b. Find the volume of B by using cylindrical method. The formula of volume for cylinder method was 2 pi integrate B to A Rx Hx dx. Rx we can know is equal to x, while the Hx we can get the formula from above to that square root of x plus 2. We can substitute Rx and Hx into the formula, which is from 2 pi integrate 4 to 0 x bracket square root of x plus 2 dx. For the next step, we can multiply the x into the bracket that will form 2 pi integrate 4 to 0 x square root of x plus 2x dx. X square root of x, we can make it to x power of 3 over 2. So the next step is 2 pi integrate 4 to 0 x power of 3 over 2 plus 2x dx. If I follow the formula of integration, the power have to add 1 and divide by the power. So 2 pi bracket x power of 5 over 2 divided by 5 over 2 plus 2x square over 2 close bracket 4 to 0. Because the divide cannot divide by another fraction, so the fraction 5 over 2, the 2 will be moved outside. So it will form 2 pi bracket 2x power of 5 over 2 divided by 5 plus 2x square over 2 close bracket 4 to 0. So for the next step, the 4 will be substituted into the x. So we will form 2 pi bracket 2 times 4 power of 5 over 2 divided by 5 plus 2 divided by 4 power of 2 divided by 2 bracket and minus 0. After the calculation, we will form 2 pi bracket 144 over 5 close bracket. We could multiply the 2 pi into the bracket, so we can form 288 over 5 pi unit of power 3.